Okay, now we're going to make a big jump here. We're going to learn about radian measures. Now, you've been doing degrees your whole life. So when you're walking along and somebody says, oh, there's an angle, and you think, oh, well, how many degrees is that? Well, I can approximate that. That's about 40 degrees. And then you walk along and somebody says, oh, no, there's another angle. Well, I can approximate that. That'd be about 100 degrees. So you've been doing this your whole life. You've been looking at an angle and thinking, all right, far out, I can estimate the degree measure of the angle based on just how wide it is between the two sides. But if you think about it, that really didn't give us too much information. It didn't tell us anything about the lengths of the sides. Doesn't tell us anything about the lengths. It just tells us kind of how wide it is. And that is an important, very important thing. But if you ever noticed on your TI calculators, when you look at the mode, the default mode on all of your TI graphing calculators is radians, because ultimately radians ends up being a more important measure as you go through your math careers. So here's the idea. You know that all the way around a circle is 360 degrees. We know that. Everybody's familiar with that. Okay. So we now know that if we start, we have an initial side, we go all the way around, we make a terminal side. So if I went one lap around the circle and stopped here again, that would be 360 degrees. So here's what was decided we would do. We're going to make a circle. We're going to make a circle and pretend this is perfect, like all my drawings. And we're going to standardize it. We're going to standardize it so that the radius is always 1 unit. So 1 centimeter, 1 mile, whatever. Then we're going to say to ourselves, if I make an angle, in there, we're going to do what's called a radian measure. And the radian measure is the measure of the intersected arc. So the radian measure actually becomes the measure of that intersected arc right there. So we usually just use R for that. We would say theta. So here's my angle theta. So we would say theta is equal to, like if I said theta was whatever, 1 radian, that would mean the length of that arc is 1 radian. So you're thinking, okay, that doesn't make any sense. Where are you going with this? All right, here we go. You know that the entire circle is 360 degrees. So the entire circle is 360 degrees. All right, we also know that the circumference of a circle is 2 pi r. R being the radius, not radians. R is the radius. So what we're going to say is, oh, therefore, if the circumference is 360 degrees, and I know that the circumference is 2 pi r, you with me? And we know that R is standardized to be 1. R is standardized to be 1. Then we'd say, wait a second. That means 2 pi, when R is 1, 2 pi is equal to 360 degrees. So 2 pi radians equals 360 degrees. Meaning the circumference of the circle, see, we're not just talking an arc length, we're talking the entire circle would be 2 pi because we standardized it to be 1, the radius to be 1. So that 360 degrees would be the same as 2 pi radians. That right there is the start of this. So 2 pi is equal to 360 degrees. 2 pi radians equals 360 degrees. So when we start to build on that, you say, okay, far out. How does that help me? If I'm talking about 90 degrees, 180 degrees, 270 degrees, 0 degrees, 360. Well, how about this? Let me see, logically, 180 is half the circle. So if the entire circle is 2 pi, then 180 would be pi radians. 90 is a fourth of the circle. So logically, the whole circle is 2 pi. So that'd be pi over 2. 270 is 3/4 of the circle. So 3/4 of 2 pi is 3 pi over 2. So we're kind of thinking, and this guy over here is 2 pi. We're kind of thinking we need to come up with a conversion factor here. We need to come up with a conversion factor. So how can I convert? Like how can I do this real quickly? What would I do for 100 degrees or 10 degrees? How can I convert back and forth between radians and degrees? So conversion factor. All right, so if we elaborate on this a little bit, if we think about it, we're saying, okay, so 2 pi is equal to 360 degrees. So if I've got some radians, like I've got X amount of radians is equal to 360 degrees, then X would be 360 degrees over 2 pi. So 180 over pi. So if I'm converting from radians to degrees, my conversion factor is 180 over pi. And then here's something that comes up a lot. If you say, well, I've got 360 degrees, how's that? And we're thinking, well, I don't know. I've got how do I convert that into radians? You'd say, okay, so that'd be 2 pi over 360, which is pi over 180. So you're thinking, So basically, one radian is equal to pi over 180. 1 degree is equal to 180 over pi. So these end up being our two big conversion factors. Because if you think like, okay, if I start with 90 degrees and I want to convert that into radians, we started with 90, we want to convert it into radians. So you know the answer is going to be pi over 2. So you say, all right, if I'm starting with degrees, I need to get pi into the answer. So 90 degrees, well, 1 radian is pi over 180. So 90 degrees would be 90 times pi over 180. So pi over 2. You say, okay, I'm going to start with 120 degrees. I'm starting with 120 degrees. So 120 degrees, 1 radian is pi over 180. So 120 degrees would be 120 pi over 180. So 2 pi over 3. And what you're going to notice is, gee, all the radian measures have pi in them. All the degree measures don't have pi. Because that's one of the things I always bring up when people say, I'm having a hard time remembering this. Just remember, when you're converting from degrees to radians, you want pi to be in the answer. So you need pi to be there. Then if somebody says, well, wait a second, I've got 3 pi over 2 radians, and I need to convert that into degrees. Well, where did my conversion go? 1 degree is 180 over pi radians. So when I multiply this out, the pi's are going to cancel. So 3 times 180, so we know it's going to be 270. I shouldn't have written a fraction there. So we know it's going to be 270 when I multiply that out. The point being, pi is gone. You canceled pi out. So when you start with radians and you're converting into degrees, you're canceling pi out. Something like 3 pi over 4. Oh, I'm starting with radians. I'm converting to degrees. So I know pi needs to cancel. So I'm going to use 180 over pi because I want pi on the bottom to cancel. And like I also said, well, if 1 degree is 180 over pi, then 3 pi over 4 times 1 degree is going to convert it into pi. So this ends up being 135 degrees. So our conversion factors, when I'm converting from degrees to radians, I multiply by pi over 180 and clean it up. When I'm converting from radians to degrees, I multiply by, I multiply by degrees. When I start with radians, I multiply by 180 over pi to convert it to degrees because I want the pi's to cancel out. So that's your converting between degrees and radians and the starting talking about degrees. And that is a huge, huge deal as we go through things.